In August 2004, the Illinois Department of Transportation, in conjunction with the Northern Illinois Ready Mix and Materials Association, the Great Lakes Cement Promotions Fund, the Illinois Ready Mix Concrete Association, and 12 concrete producers, conducted a demonstration of the techniques involved in white topping sections of the parking lot at IDOT District 1 headquarters in Schaumburg, Illinois. The existing parking lot was due for resurfacing, with cracks, puddling, potholes, and overall deterioration. After resurfacing with asphalt many times, IDOT was ready to take a closer look at concrete overlays, not just for parking lots, but as a test case for determining specifications for the use of overlays on roadways. This video tells the story of the demonstration. On the first day of the pour, IDOT officials held an open house and outlined the dimensions of the project.
So the purpose of this demonstration is to take a look at differing specifications for white topping to determine how each one performs. We're modifying some different areas. We're doing a 2-inch, a 3-inch, and a 4-inch overlay. We're going to do a 6-inch insert. We're going to be utilizing different fiber content.
This is a demonstration project. This is being done for the Illinois Department of Transportation, donated by quite a few member companies and about 3 or 4 different organizations that are contributing to make this possible.
IDOT, in conjunction with industry guidance, developed the project standards, including the concrete mix, the type and weight of fibers, the depth of the concrete poured, and the spacing and timing of the saw cuts.
We are attempting, with this demonstration, to reduce the cost significantly. One of the things we've done is reduce the amount of cement from the traditional 833s and 758s to basically a bridge deck compensated mix, 600 total weight of cementitious with about 15% fly ash.
The unique thing about this is we have incorporated the structural fibers. We use 2 dosage of fibers in this project. The dosage of fibers is a function of the anticipated design thickness of the slab and what we're putting down in different locations. The actual tensile properties of the fibers that we're looking at out here today are on a par with steel. One of the things people always ask you with the structural fibers is how much capacity can you get out of it? More importantly, how far can you stretch out the joint spacing?
So we're trying to experiment here with the 2-foot, 3-foot, 4-foot joint spacings to see exactly where we need to be with the fiber contents to figure out what we need for the optimum design for the specification.
Successful white topping relies on a good base. For this project, IDOT milled the surfaces to the specified depths 2 days before the pour.
Your pre-construction requirements, as far as the formwork and things, are just they're minimized or just removed.
The contractor, Swiderski Construction, used a laser screed to speed up the placement and to satisfy the various depth and contour requirements of the lot.
In the last 3 to 5 years, technology has taken laser screeds into a 3-dimensional mode. Today we can do multi-slope pavements with any types of crowns, swales, different pitches, flow lines in a pavement. We can change thicknesses as we're doing out there from 2-inch to 3-inch to 4-inch to 6-inch, and all in one pass. The surface elevation is determined by a geodometer, which is a total station. It's a fully robotic survey piece of equipment that's linked by a radio transmitter to a laptop computer on board the machine. That laptop is then linked to servo motors, which run the hydraulics on our machine to set the elevations. That laser screed then screeds it off. It plows off the first pass of concrete. The next pass is an auger that's going to cast away any excess material off to the right side. And then following behind that is a vibrating plate that consolidates and vibrates the concrete at the surface to bring up a little mortar. Behind that is a crew with bull floats and putting a broom finish on.
IDOT introduced the use of early entry saw cutting on this project. Early entry saw cutting, or soft cutting, creates less dust and noise, reduces wear on the blades, and allows cutting at a faster rate, which helps to speed production.
You transfer the load from one section to another with a saw cut that creates a crack. Concrete does crack. Concrete is supposed to crack. We want it to crack where we want it to crack.
Usually saw cutting can be one of the most expensive things you're going to have on a project like this. So if you can reduce your saw cuts, but still not have the susceptibility to curling or cracking, you're going to be saving time and money.
The question gets to be, how far can you stretch those joints out? We're looking at 20% on the lower dosage fibers and potentially 30% joint space increase on the higher dosage fibers. When we think about what that translates out into sawing costs, that's a tremendous amount of sawing costs that you can eliminate.
Another aspect of the test is finishing and curing. Since parking lots combined low-speed auto traffic and pedestrians, the contractor used a broom finish. They also used evaporation retarders and a Type 3 curing compound to control shrinkage cracking. White topping has a number of benefits, including durability, flexibility, cost effectiveness, speed of construction, and safety.
Concrete overlays historically have lasted 2 to 3 times longer than your typical asphalt mill 2 inches and fill 2 inches back. We think this is very significant for the taxpayers.
You want to be able to compete with asphalt in this type of a market. It's the city street market, the local roads market, the parking lot market. Go down to Woodfield Mall and you see that huge parking lot. There's a couple hundred acres out there. What's their solution? They always go out there and they use asphalt. And every 5 years they go out there and they use more asphalt and more asphalt. We can go out there with the techniques that we have today, using the materials we have today, and virtually assure a developer or a mall owner, 20 years of trouble-free service. Now, you don't get that out of asphalt. This is a good system.
Concrete overlays lend themselves to fast-track construction.
We were talking to materials engineer. He says it's basically ready to go now on the stuff we placed yesterday. 3,500 PSI is what they had on the strengths on the cylinders, and 3,000 PSI is opening. So we could go and put cars. When you hit basically final set on concrete, you've got enough strength to put automobiles on it. So for those developers and mall owners that are worried about being shut down in the area for a long time because we got to cure concrete for 14 days or 28 days or some old myth about 7 days, that's just not true. You need to understand the materials. You'll get the concrete down, and as soon as you can get her cleaned up and striped, you can get back on it.
Concrete has the added benefit of reflecting light, which provides safety and security.
Concrete is white, and it does have reflective characteristics. Some of the areas that we're looking at putting in concrete overlays are where we have inadequate lighting, and this would enhance the lighting.
The future of concrete overlays is bright. The technology, mixed designs, and construction techniques demonstrated at IDOT are opening markets that have been dominated by asphalt.
The parking lot market is huge. The National Ready Mix Concrete Association has a national program going to resurface parking lots, and instead of having to seal coat or resurface by milling and grinding and filling, replacing every 2 to 3 to 5 years, we can now put a thin concrete overlay down and have the concrete parking lot last 25, possibly 30 years. Asphalt is a good product. It's been used throughout this country. However, in our opinion, it is overused. In areas such as intersections, where there's turning motion, stopping and starting, the typical bituminous pavement, you experience rutting, shoving. We've all seen it in our driving lives. This can virtually eliminate rutting and shoving of the softer bituminous pavement. We think this is good for arterial streets, truck traffic. We've used them now in the city of Chicago for their bus pads.
The trend is to move towards highway types of construction. Local roads is proven. Highway types of construction, though, where we have the heavy loads, we're having to look at new ways to deal with it. The structural fibers that we're implementing in this particular project give us the opportunity to look at that. IDOT's interested. They've got the opportunity to look at. They'll watch and monitor this lot every day.
With new technology, faster computers, and better modeling techniques, new solutions in concrete paving will emerge.